Hi all, welcome to Clear and Concise. Let's have a look at this question. A 50 kg block is suspended by a spring of stiffness 10 kilonewton per meter. So there is a spring whose stiffness is 10 kilonewton per meter and a mass of 50 kg is suspended from the spring. Now, if the block is pulled 40 mm down from its equilibrium position and released. Now this block is pulled 40 mm downwards and released. The maximum acceleration, we need to find the maximum acceleration reached by the block. We know the governing equation of spring mass system is mx double dot plus kx equals to 0. Here x double dot is acceleration, x is displacement or amplitude. Okay, now we need to find acceleration x double dot, that is equals to minus kx by m. Here the negative sign signifies the acceleration is always in the opposite direction to the displacement. Acceleration is always opposite to the motion or direction of the displacement. Now we know k, that is 10 kilonewtons, so 10 into 10 cube times displacement, that is 40 mm, converting it into meters, 40 into 10 power of minus 3 meters, divided by mass, that is 50. We yield this 10 cube and 10 power minus 3 gets cancelled. This 0 gets cancelled. Now 5 ones are 5 eights, 5 ones are 5 eights, so 8 meters per second square. This is the maximum acceleration. So the correct answer is option D. It can be solved by other way also, that is general solution for the spring mass system, which is following simple harmonic motion, can be given as x equals to a sine omega t, where a is the amplitude. Now displacement is given like this. Now velocity is first derivative of the displacement, so a omega cos omega t. This is the first derivative. The second derivative is acceleration, that is equals to minus a omega square sine omega t. The maximum acceleration, so x is maximum when omega t is equals to 90 degrees. So when omega t is equals to 90 degrees, so sine value is maximum, that is equals to 1. So the maximum acceleration is x double dot is equals to minus a omega square. We know omega square is equals to k by m. Omega square is equals to k by m. So again we will get same k by m times amplitude x. So if we solve by using this method or else by the above method, we will get same answer, that is 8 meters per second square.